Hello everyone, I'm Hari Prudhvi from CSE-A section and my topic is automated greenhouse control system. The aim and objective of the project is it is a possible solution that will likely involve household growing, which is a reasonable percentage of the vegetables and crops they need in a greenhouse which does not require too much land and space. The automated greenhouse control system achieves monitoring and control of a greenhouse environment by using sensors and actuators which are under the control of a microcontroller running a computer program. The world climate change has brought about unpredictable weather conditions that have resulted in global food shortage, and a greenhouse will normally produce more crops per square meter when compared to an open field cultivation, since the microclimatic parameters that determine crop yield are continuously monitored and controlled to ensure that optimum environment is created. The system is compared of two stations, remote monitoring station and the actuator sensor station. The controller used in actuators and sensor station, which ensures that the microclimatic parameters stay within predefined values as determined and set by the user in the Arduino prototyping platform. The climatic conditions of the greenhouse and state of the actuators are transmitted to the remote monitoring station via a pair of low power XP modulator demodulator. The codes for the controller are written in Arduino programming language, debugged, compiled, and burned into the microcontroller using Arduino integrated development environment. A scaled down prototype of the system was built and tested. Automation of greenhouse brings about efficient data acquisition and control of the microclimatic parameters. It also significantly reduces the labor involved in its maintenance, thus making the system useful for rural farmers, small-scale agriculturists, gardeners, and agricultural researchers. The definition of the problem is the automated greenhouse control system, whose block diagram is made up of two principal units, sensors and actuator station and a remote monitoring station. These two units consist of sensors for lighting, temperature, humidity, and moisture, fan, fogger, drippers, and an artificial light. Arduino microcontroller board, XB modems, XB adapter board, and a computer of your own choice. The sensor station is the heart of the systems that is responsible for regulating the greenhouse environment. The sensors acquire the environmental data. After the data have been filtered to remove noise, they are made available to the Arduino board, which they then computes the current values of the control variables and compares them with the set thresholds. If any of the control variables is outside a safe limit, the corresponding actuator is activated to restore the optimum condition. The Arduino board also reads the state of the actuators and transmit the information along the current values of the control variables to the remote monitoring system via XP radio frequency, a modem pair that requires that at a frequency of 2.4 GHz. A large number of wireless linking devices exist. However, XP has been used for this work primarily because of its sustainability for low power data transmission. Background of the idea and who is it for? It is mainly focused on industrial sector, transportation sector, and agricultural sector. Companies in the industrial sector include manufacturing, constructing, and energy production are significant potential users of an automated greenhouse gases system. These industries are major contributors to the greenhouse gas emissions and are under increasing pressure to reduce their environmental impact. Transportation sector. This sector, including airlines, shipping companies, logistic providers, is a potential market for the system. These industries are significant contributors to greenhouse gas emissions and are under pressure to reduce their carbon footprint. Agricultural sector. This sector is a significant contributor to greenhouse gas emissions, and farmers and food producers could benefit from an automated greenhouse gases system to monitor and reduce their emissions. Uh, what will it do? Use of artificial intelligence and machine learning, development of Internet of Things. So The use of AI and ML algorithms will enable the system to identify patterns and trends in greenhouse gas emissions data, facilitating more effective monitoring and management of emissions. The development of IoT devices is expected to enhance the functionality of an automated greenhouse gases system, allowing for real-time monitoring and managing of emissions from various sources. Overall, ongoing technology developments are expected to enhance the functionality and capabilities of an automated greenhouse gases system, providing more comprehensive monitoring and management of greenhouse gas emissions and contributing to a more sustainable future. Government and regulatory agencies. These are also potential users of the system as they seek to monitor and enforce environmental regulations and reduce greenhouse gas emissions across various industries. Potential markets. The market potential for an automated greenhouse gases is significant, giving the increasing focus on sustainability and environmental impact across various industries and sectors. The potential market size can be segmented into various industries and target users or customers, including industrial sector, transportation sector, agricultural sector. Companies in the industrial sector, including manufacturing, construction, and energy production, are significant potential users of an automated greenhouse gases system. These industries are major contributors to greenhouse gas emissions and are under increasing pressure to reduce their environmental impact. Transportation sector. The transportation sector, including airlines, shipping companies, logistic providers, is also a potential market. These industries are significant contributors to greenhouse gases and are under pressure to reduce their carbon footprint. And the agricultural sector is a significant contributor, and farmers and food producers could benefit from an automated greenhouse gases system to monitor and reduce their emissions. Regulatory and governmental agencies. These agencies are also potential users of the system, as they seek to monitor and enforce environmental regulations and reduce greenhouse gas emissions across various industries. The main point, the potential market size for an automated greenhouse gas system is significant, with the global market for greenhouse gas monitoring and reporting estimated to be worth over $2.5 billion by 2026. This market is expected to grow at 10.2% during the forecast period, driven by increasing regulatory pressures, need for improved environmental monitoring, and a growing focus on sustainability and corporate social responsibility. Overall, the scalability of an automated greenhouse gas is significant, with potential users across various industries and sectors, and a growing market demand for more effective greenhouse gas monitoring and reporting solutions. Unique features of the project: lower emissions, resource efficiency, improved waste management, increased transparency, enhanced reputation. The system helps companies and governments reduce their greenhouse gas emissions, contributing to a more sustainable future and reducing the impact of climate change. By identifying areas for improvement and suggesting strategies for reducing carbon emissions, the system can help companies and governments become more resource efficient, reducing waste and promoting sustainability. The system can help companies and governments improve their waste management practices, reduce emissions from landfills, and also other disposal facilities. The system also provides transparency and accountability, allowing companies and governments to track and report on their greenhouse gas emissions. This promotes transparency and accountability and helps ensure that companies and governments are taking steps to reduce their environmental impact. By demonstrating their commitment to environmental sustainability and reducing their greenhouse gas emissions, companies and governments can enhance their reputation with customers, investors, and the public. Overall, the environmental friendliness aspects and the related benefits of an automated greenhouse gases system are significant, promoting environmental sustainability, reducing greenhouse gas emissions, and contributing to a more sustainable future. These are some of the designs and drawings of the prototype. Conclusion. The automated greenhouse control system that has been successfully designed and built is the work is meant to protect seedlings in nurseries from intruders and also grow them to maturity should be the need and arise using a very small area of land opposed to open field cultivation which may require more square meters of land to produce the same amount of crops. The system produces healthier crop since pests are usually kept away from the greenhouse enclosure. The system's reaction time to restoration of various of microchromatic parameters suffers from a few seconds delay because of the program scan cycle and the electromagnetic relays used. The system is fully automated as it does not require any form of adjustment from the user. The microclimatic parameters are also available at a remote terminal for the user to read and to monitor the performance of the greenhouse. Thank you.